Okay, so here we are with a little preview to the exponential chapter in pre-calculus here. So we're going to review some exponent rules today. So it says simplify each of the following leaving no parentheses. So when we multiply bases that are the same, we add the exponents together. So a to the m times a to the n would be a to the m plus n. We're going to add the exponents. You cannot combine m and n. When we raise a base with an exponent to a power, we're going to multiply the powers. So this would be a to the m times n. When you raise two bases to a power, it's the same thing as raising each base to the power. So we could write this as a to the k, b to the k. When we do simplification with division, this is a to the m divided by a to the n. So if I wanted to combine this into a single base, I would subtract the exponents, a to the m minus n. When I'm raising a fraction to a power, I can raise the numerator to the power and the denominator to the power individually. And when I see a negative exponent, it never makes the base negative. It just says one thing. It says flip the base over. All right? So technically this is a over 1. Flip the base over, and by the way, when you flip the base over, now you can make it positive, which means we have 1 over a to the m. Same thing in number 7. I have a negative exponent. It means take your base and flip it to the other side of the fraction. That's b to the power of positive k right there. All right? So just some exponent rules we're going to need to know for this unit. Roots, on the other hand, can be written with two different types of notation. There's rational notation, what we call rational exponent notation, or radical notation. Radical is the one that most people have seen for on and on and on for most of their mathematical career. And so what we want to do is we want to be able to convert back and forth depending on what's going to work the best. So when I look at this base of 8 to the power of 1/3, what does that really mean? Okay, what it means is it means 8 to the first power taking the cube root. So the number in my numerator here, okay, that 1 there, that is the exponent. That's the exponent. Oops, spelled that wrong. Let's try that again. Exponent that attaches itself to the base when you convert it to a root. The number in the denominator here is called your root index. Root index. A root index is the number that goes in the little crook outside the root. In a square root, like that, let's just say this was the square root of 8, there's an invisible 2 in the crook, and that's why we say square root. All right, this one happens to be a cube root, but it could be a 5th root, 4th root, or whatever. But both of these notations, 8 to the 1/3 power and the cube root of 8 to the first, these are both asking for the cube root or 3rd root. You could say it either way. You could say cube root or 3rd root of 8, which is 2, since 2 to the 3rd power is equal to 8. Okay? So let's take a look at some examples. All right? So I have 64 to the 1/3 power. This is the same as seeing 64, take the cube root of that to the first power. Now the first power really doesn't matter here, so I really don't need it. It's just where does it go when I convert it. So the cube root of 64 is just 4. That's what 64 to the 1/3 is. 625 to the 1/4 power. Okay, so I got two things going on here. Number 1, I have a fractional exponent. Number 2, it's negative. So the negative here says to flip or reciprocate. All right, flip or reciprocate. So one of the first things I could do here is I could flip this over. So I'm going to make this 1 over 625 to the positive 1/4 power. All right. The other way to look at that would be to say, well, what does that look like if we were to change it to a square root? Well, that's the same thing as the fourth root of 625. Okay, so I go through and I do some math. I figure out that 5 to the fourth power is 625. So I know that the fourth root of 625 is just 5. 36 to the negative 3/2 power. All right, when I see that negative exponent, until I get really proficient with this, I'm just going to go ahead and flip it. This is 1 over 36 raised to the positive 3/2 power. Okay, well, what does that mean? Positive 3/2 power. Well, let's rewrite it. This is 1 over, I'm going to take 36, and I'm going to raise it to the third power, and I'm going to take the square root of that. Remember, the number in the bottom is your root index. Now, I can do this two different ways. I can either take the square root first, or I can cube it first. I don't know about you guys, but taking the square root of 36 is a lot easier. So this turns out to be 1 over the square root of 36 is 6, and I raise it to the third power, and I'm not sure what that is. I think it's 216. All right? Okay. To simplify rational exponents, there's a rule that we can use if it makes sense to you, and it basically goes like this. It says, look, if I'm going to take a to the m over n power, a lot of times, just like I did on my previous problem, I took the square root of 36 before I cubed it. Well, one of the things I can do here is I can say, look, I'm going to do a to the 1 over n. I'm going to do that first, and then I'm going to take whatever number I get for that, and I'm going to raise it to the mth power. Again, that's exactly what I did on that previous example. I took the square root of 36 first, and then I raised it to the third power. So once you get the hang of this, you don't need to write them all out, but basically it works like this. I want to take 8. Whoops. Not sure what's happening here. It's all right. We'll go back. So I want to take 8, and I want to raise it to the 1/3 power. But in order to do that, I have to square it afterwards. So that 2 came from right there. Well, 8 to the 1/3 literally means the cube root of 8. Well, the cube root of 8 is simply 2. And then I raise 2 to the second power, and I get 4. Next one, 32 to the negative 2/5. Okay, negative exponent, light goes off in my head, let's flip it over. This is 1 over 32 to the 2/5 power. Okay, now let's deal with the exponent. So I'm going to look at this as 1 over 32. I'm going to look at it to the 1/5 power, but after I raise it to the 1/5 power, then I need to square it again. Well, 32 to the 1/5 power is 2. So this is 1 over 2, and again I have to square it, so it becomes 1/4. All right? Not sure what happened with letter C here. We lost our problem here. So this is 36. No, excuse me, wrong one. This is 64 to the negative 4/3 power. So again, I'm negative, I'm going to flip it. 1 over 64. At the same time, well, I'll put all the steps in, so this would be 4/3. All right, I do not want to raise this to the 4th power. I have no idea what 64 to the 4th power is. So I'm going to look at this as 1 over 64 to the 1/3 power. That's going to be a lot easier. But since I took the 4 off of the fraction, I need to raise the whole thing to the 4th power. 64 to the 1/3 power is just 4. So this turns out to be 1 over 4 to the 4th. And then if I really wanted to, I could multiply that out, and I believe I get 256, if I did that correctly. All right? All right. So now we want to be able to go backwards. We want to be able to look at a root notation, and change it back to an exponential notation, because when I look at this guy right here, this is the 5th root of 8 squared. Well, I know I can't take the 5th root of 8. So trying to do the root first here isn't going to work out for me too well. So my root index is the 5 on the outside. My exponent on the 8 becomes the numerator in my fractional exponent, and the root index becomes the denominator in the fractional exponent. So 8, the 5th root of 8 squared would be 8 raised to the 2nd power with a denominator of 5. Okay, so exactly the opposite of what we were doing. Now, why do we need to know how to do this? Because you cannot take the 5th root of 8, and I'm just going to knock off the 2 for now. I cannot take the 5th root of 8 and multiply it by the square root of 8. I can't do that because my root indexes are not the same here. So that's a no-no. But if I change these to rational exponents, to fractional exponents, then I can do that work. All right? So number 4 says, all right, let's take a look. I want to do 27 to the 1/3 power times 27 to the 4/3 power. What's the rule for in multiplication? All right, so the rule here is if the bases are the same, then I can add the exponents. So from the front side, this would be x to the a plus b. I can't combine those because they're not like terms. So I have two bases, 27 and 27. All right, they're being multiplied. That means I can add the exponents. So this is 27 to the 1/3 plus 4/3. Let's add the exponents. They already have common denominators, so I get 27 to the 5/3 power. And again, thinking about how to simplify this, I'm going to take the cube root. So this is the cube root, and I'm going to do that first. So the cube root of 27 would be 3, but then I have to raise 3 to the 5th power, and I don't care what that is. I think it's 243 or something, but I don't care. Letter B, 5 to the 1/3 times 5 to the 1/4. Now again, this is a prime example. This is the cube root of 5 times the 4th root of 5. That's a no-no the way those are written right there. I can't do anything with that. However, if I keep them as exponents, 5 to the 1/3 and 5 to the 1/4, then I can do something. I can do 5 to the 1/3 plus 1/4. The only difference is I have to change the denominators so that they're the same. So I'm going to make a denominator of 12 here. So I'm going to do 5 to something over 12 plus something over 12. The second fraction gets multiplied by 3 over 3, so my numerator would be 3. My first fraction gets multiplied by 4 over 4. Now I can add these up. This is 5 to the 7/12 power. All right? What do we got down below here? Number 5, we simplify each. All right, so this is just a little bit of order of operation stuff here. You'll notice I've got 16 to the negative 1/4. I cannot divide 16 and 2. Why can't I do that? Because exponents come before division in the order of operations. All right? So I've got a couple of rules I need to deal with. Number 1, I've got negative exponents. So anytime I see a negative exponent, I can flip it to the other side of the fraction bar. So if it was x to the negative a, this would be 1 over x to the a. Or if it was 1 over x to the negative a, it just becomes x to the positive a. So the first thing I'm going to do here is I'm going to take that negative exponent, I'm going to move my base 16 down to the bottom. This is now 16 to the 1/4 power times 2. And since there's nothing left in the numerator, I leave a 1 up there. Well, 16 to the 1/4 power has to be done before I multiply by 2. So the 4th root, that's what this is asking for. The 4th root of 16 is 2. Times the 2 in the denominator, and I end up with 1/4. So this one, letter B, I've got 2 to the negative 1. Immediately, I'm going to drop it down to the bottom. I want that exponent positive. 4 to the negative 3 halves, I'm going to bring it up to the top. 4 to the positive 3 halves. Before I can divide 4 and 2, I've got to do 4 to the 3 halves power. Well, what does that mean? It means take the square root of 4. So that's 2 to the 3rd power over 2. Now I have two choices. I can multiply out 2 to the 3rd, which is 8. So I'll go ahead and do that. That's 8. And then I can divide 8 by 2, and I get 4. Or, because I know my rules of exponents, this is 2 to the 3rd over 2 to the 1st. The rule for exponents says to subtract the exponents. So this is 2 to the 3 minus 1 power, which equals 2 to the 2nd, which equals 4, just like we got above. Nice how that works, isn't it? All right, next one. The rule for division, if the bases are the same, a to the k over a to the p, I can do a to the k minus p, or I can do a to the k over a to the p, and I can subtract like this, a to the p minus k. Now, why would you ever do that? Well, if the exponent on the bottom was bigger, I would subtract down below. We'll see that in example B in a minute. So I've got 3 to the 2/3 and 3 to the 1/4. Obviously 2/3 is bigger than a 1/4, so I am going to do 3 to the 2/3 minus 1/4. I need some common denominators again, so that's going to be 12 again. So this is going to be 3, multiply the first fraction by 4 over 4. So that's going to give me 8/12. Multiply the second fraction by 3 over 3. That's 3/12. Now I can subtract my fractions, and I get 3 to the 5/12 power. I have no idea what that is, don't really care. Next one, you'll notice 2 to the 6/5 on the bottom is 6/5 is bigger than 1/5. So instead of subtracting from the top exponent, I'm going to do this. I'm going to do 2 to the 6/5 minus 1/5. That means I'm bringing the 2 in the numerator down to the denominator, which means I got to leave something in the numerator again. Well, if you do 6/5 minus 1/5, that's 2 to the 5/5. But 2 to the 5/5 is just 2. That the whole mess turns out to be 1/2. All right? Okay, that's it for this one. Wow, that was easy, I hope. Bye-bye.